In this video, we're going to start talking about gravity causing objects to fall. So here's the example. The stone is dropped from rest from a 30-meter high building. How long will it take to reach the ground? So again, we're going to try and find our given. The obvious one is this height, okay, 30 meters. So it's going to fall 30 meters. So that's my distance. I'm going to say that's 30 meters. Okay. Now, the other ones are kind of subtle. And I need 3. And it says it's dropped from rest. Okay? That means it's not being thrown downward, thrown upward. It's starting with a velocity of 0. Starting velocity, we use v0, is 0. And the other thing, up above, I mentioned that for gravity, if we're near the surface of the Earth, the acceleration is 8 meters per second squared. And remember, we're probably just going to use 10 because it makes our math easier. And then my unknown is time. Okay. So now I have to find an equation that has those 4, delta x, v0, a, and t. And if I look back up here, the one that has those is this third one, delta x, v0, a, and t. So I'm going to copy that equation down. Delta x is v0t plus 1/2 at squared. Okay, delta x is 30. v0 is 0. I don't know t. The acceleration is 10, and I still don't know t, so it's t squared. Now for this one, 0 times t, no matter what the t is going to be 0. 0 times anything is 0, so that part goes away. This becomes 30 equals f times 5, t squared. Okay. Now, I would divide both sides by 5, and I get 6 t squared. So the time is going to be the square root of 6, which ends up being 2.45 seconds, if I round it. Okay? Now, our next problem is going to be a little different. It's going to be thrown upward. This one I'm going to draw a picture for. Okay? I'm going to take the object, I'm going to throw it upward. Okay? Its initial speed is going to be 30. Okay? And it's going to go up, and then it's going to come back down there. And again, this one's kind of subtle because there's other givens in here, and I don't have the numbers written out. But if you remember, it's gravity, so my acceleration is going to be, we're just going to skip right ahead and use 10. Now in this case, my velocity's up. My acceleration is down, okay? And these are vectors, so direction is actually important. So if I'm going to call 30 positive because it's up, I'm going to call the acceleration negative because it's down. In the second problem, everything was moving down, everything was the same direction, so I didn't have to worry about it too much. But in this problem, I really have to be careful. And then I'm looking for time. Now, if you remember, I said we always have to have 3 variables. And the trick to this one is this. If I throw something up in the air, there's a very unique point, okay? And that's at the top, okay? On its way up, it's moving upward. It has a positive velocity. On its way back down, it's moving downward, so its velocity would be negative. Right at the very top, it's not moving up, it's not moving down. The velocity is 0 at the top. Okay? Now I have 3, like so. My easiest one to use in this case is going to be number 2 here. V is v0 plus at. So, v is v0 plus at. My velocity is 0 equals v0 is 30 plus my acceleration is negative 10 times t. I would subtract 30 from both sides. And then my time ends up being 3 seconds. Now, that's why I wanted to have that acceleration negative. If I don't, I end up with a negative value for the time, which doesn't make any sense. So, remember, we're not quite done with the problem, though. That's to the top. If I want to know the total time in the air, this is symmetrical. If it takes 3 seconds to go up, it's going to take 3 seconds to go down. So t is 6 seconds total. Okay? Now, I mentioned this before. That's assuming there's no air friction. Air friction would actually make it go a little bit slower on the way down than it did on the way up. But we're going to pretend that that doesn't exist because that becomes a very, very difficult problem.